All right, so today we're going to start a new lecture, a new chapter in our journey through science, which is a great time. I'm sure that you agree, but it's a wonderful experience going through science at 5 o'clock in the evening. So, yeah, it's a good time. Anyway, our next chapter is about motion. We're a little bit behind, but that's okay in the schedule, but that's okay. Our next chapter is going to be about motion, and so we're going to spend a lot of time, probably the next 3 lectures, talking about motion and classical mechanics and Newton's laws and all that stuff, right? Uh, but there's going to be a lot of math, so be prepared for that. Um, Not hard math, but just algebra kind of stuff. Algebra kind of stuff. Okay, so let me go ahead and make sure my pen is working, which I finally got all my new technology from the school, so everything should be working well now. The first thing I want to talk about then is physics. It's going to be the very first science discipline that we dive into in this class. And physics deals with many different things, right? Matter, motion, force, and energy. Specifically, there's classical mechanics, which is things like Newton's laws. And then there's sounds and waves, thermodynamics, electromagnetism, optics, quantum mechanics, atomic and nuclear physics, and then relativity, right? So all those things are physics, and we're going to touch on each one of those a little bit in this class, right? Each one of those a little bit in this class. So the very first question I want you to answer is this one here, right? Go ahead and pull out your phones and scan the question. Which of the following is not a topic covered in physics? We have chemical equilibrium, thermodynamics, quantum mechanics, relativity. I literally just went over this, so hopefully everybody gets it right. 3 responses already. Good job. Don't forget to do this. This is also going to be your participation grade and your attendance for today too. So, which of these is not covered in physics? Chemical equilibrium, thermodynamics, quantum mechanics, or relativity? You having trouble there, Derek? Is it standing now? Or did you get it? Got it? You still don't have it? No, this is the answers. Oh, you just read the wrong angle there. Okay, we've got 18 responses so far. We're missing Jasmine, so she hasn't done hers yet. But what was that, 5 over there? 5 there. That's 10. Wait, that doesn't make any sense. 5, 5, 10. Okay, yeah, okay. There's 5 there. That's 15, and then 6, 7. So we're waiting for 2 more responses. What happened? Your phone just died? Really? Talk about bad luck, man. Actually, Daniela didn't do one either. Oh, so there should be 3. We're missing 3. Okay, that's fine. No big deal. They can answer other questions. Um, Juan, I need you to write down what you're, since you're not going to be scanning any of the questions today, I'm not going to even know you're here today. So I need you to write these things down because scanning actually puts you in attendance too. All right. So let's see what everybody said, and IT still has not fixed this problem for me yet, so I still have to turn my screen around to show you. The vast majority of you said that the answer is A, which is chemical equilibrium. That is correct. Chemical equilibrium is the one that is not covered in physics. It's covered in chemistry. We'll talk about that later on in the semester. So good job. Good job. Did you get it, Juan? Okay. All right, so let's define motion, right? So motion is a couple different things you can use to define it, right? But it really is an object that is undergoing continuous change in position, right? Of course, the position is the location of an object. Uh, and so we can actually describe motion as a time rate of change of position, right? Like for example, we can describe this motion here of this cheetah going at a certain miles per hours, miles per hour, right? Or we can describe this bullet here that's flying through this playing card as also a rate of motion, right? Some kind of rate. Um, so what am I talking about then when I'm talking about the rate of speed of something, right? Or the rate something's traveling, for example, that bullet or that cheetah? Well, uh, it's actually velocity is what I'm talking about, right? The velocity of something, okay? The velocity. Speed is a scalar quantity, right? And so the uh, when you talk about speed, all you're really saying is, hey, this car, for example, is going 80 miles per kilometer, right? Uh, 80 kilometers per hour, right? But to make it a little bit more specific, what you can say is this car is going 80 kilometers per hour in north, right? And so the difference between just saying speed and saying velocity is that speed only has a magnitude or how fast you're going. Whereas a velocity, it is a vector, right? And a vector has both a magnitude and a direction, right? And that's why you say a car is going 80 kilometers per hour north, right? Vector quantities may be represented by arrows most of the time, right? That's what we do. And these arrows actually will be proportional to the magnitude. So you can see here that there's a 40 kilometer per hour going towards the right, and then the 80 kilometer per hour is going towards the right as well, and the arrow is twice as long as that 40 kilometer per hour. They can also go backwards too. Minus 40 kilometers per hour can go backwards, minus 80, and also notice again that the proportion of the arrow size is twice the size of the minus 40, right? So when we draw vectors, we do draw them so that they are proportional to the magnitude that we're trying to draw, right? We're trying to represent rather. I better make sure that I'm actually recording this so that you guys can go through the notes again. Let me make sure, because that would be really bad if I'm not recording it. And yes, I am recording. Okay. Okay. So like I was just saying before, though, vectors can go forwards and backwards, right? We have a man here going forward here, right? So when you have a forward vector, it's v plus, right? A plus sign, and then which is a positive going forward here, but then you're going backwards in relation to that, then it's negative sign, of course, right? Uh, and so that's literally what it says down there. Vectors can be both positive and negative. That's all I need you to know from that slide. So let's take a closer look at speed then. Okay, speed is really the distance traveled divided by the time it took to travel that distance, right? So, for example, if I'm saying that I'm going 60 miles per hour, right? What that means is that if I'm driving for an hour and I'm going 60 miles per hour, what that means is then that in that hour I will travel 60 miles. Okay? So really it is a distance traveled divided by a time traveled, the time it took to travel that distance, right? And so you can have this formula right here that will tell you what the velocity is. And when you have this little line over the velocity, that means the average velocity, right? That's the average velocity. And so literally the average velocity is the distance divided by the time, or the distance, the change in distance divided by the change in time, right? Which makes sense because if you're traveling, you're going to change, the distance you have traveled has changed, right? You started somewhere, like say at 0, and then you moved to 5 miles away from yourself, right? Or away from where you were before. And then it also took you some time to do it, right? So say it started you at 0 seconds, and then um, it took you 5 minutes or 10 minutes to walk 5 miles. Wow, that's really fast, right? So I will ask you questions that are going to be like, calculate the average speed, and the average speed will be the distance traveled divided by the time it took to travel that distance. Okay. Um, yes, yes. Okay. So this is your next question. Which one is not? Oh, sorry. Which of these is a unit of speed? Which of these is a unit of speed? I try to put the thing on this side so it'd be easier for you to scan. I'm not blocking it, but maybe I should just put it over here. I'm sorry, Derek. This is not a problem in the other classroom. I wish I had the other classroom. Are you on the Wi-Fi? Which Wi-Fi are you on? The secured Wi-Fi? Excuse me. You won't be able to get there if you don't get on the Wi-Fi, because yeah, you have to log in first too. This is how I'm actually ensuring that you're here, because you have to log in with your username and password. All right, 11 responses so far. Which of the following is a rate of speed? Is that working? The last one worked. Is anybody else having problems? Well, of course not, because there's already 18 responses. Here, let me try for you. Now I'm too close. There you go. Yeah, sure.
Sorry, thank you.
It's okay. There you go. Sorry about that. I didn't mean to crash into you with my fat stomach. Okay. You get it? Is that working? Was it working before? Is it working? Okay. Yes, we only need one more response. I think that's you. Okay, so the answers are up here. The vast majority of everybody put all the above. That is correct. That is correct. Miles per hour is definitely a speed, right? Meters per second is a speed. Kilometers per minute is also a speed. Good job there. Good job there. All right. So let's keep on trucking, right? So velocity is similar to speed, except that it has a direction involved, like I just said a second ago. Lost my laser, right? So there's displacement, right? Which is a straight line distance between the initial and the final position of the direction that you're going to. So say you're in your hometown here and you're going to the state university. This is called the displacement right here. Okay, the straight, like the, what do you call it, the crow, the distance as the crow flies, or something like that. Something that old people say, I guess. The crows fly this distance. Anyway, so that's called the displacement, right? And then the distance is actually the path that's traveled, right? So if you're going to go over here to 97 kilometers or 60 miles over here, right? Or you're going to go over here to go to Podunk first and then go to State University, right? Those are both distances here. But if you're talking about the straight line distance between your hometown and State University, that's called the displacement, right? So you can also get the average velocity, right, by dividing the displacement by the total travel time, okay, by the total travel time. Everybody understand that? That makes sense, right? Everybody know the difference between um, distance and displacement? It's a little confusing, but what can you do? Okay, so yeah, please don't write all this down. I will post the correct notes right after class. I promise. I'm so sorry about that. Okay, so let's try a problem real quick. Okay, let's try a problem real quick. Let's describe the speed of this car. Okay, so the first thing we have to take note of is the fact that this car, from here to here, right? It traveled 40 meters. I'm sorry, 80 meters. It traveled 80 meters. Okay. The other thing to take note of is that it started at 0 seconds, of course, and ended at what? 4 seconds. And previously, I already told you, right, that the formula for the velocity, the formula for the velocity, is literally v equals distance divided by time, right? So all you have to do is then say that equals then 80 meters for every 4 seconds, right? And then, so we can divide 80 divided by 4, right? And that gives us 20. That's called head math right there. And then we have both meters per second there. Nothing cancels. So our unit now will be meters per second, right? Meters per second. Um, so how many significant figures? Is this correct for significant figures? It is, right? Because our lowest number of significant figures is one significant figure right there. This also has one significant figure, right? 80. The reason why it has one significant figure is because there's no period. There's no decimal point at the end of the zero, right? So the zero doesn't count as a zero that's a placeholder is not a significant figure, right? So both of these have one significant figure. So your 20 meters per second has one significant figure too. And so that would be uh, uh, our rate of speed, right? But then you also need to add to it a direction to actually make it a velocity. And I'm going to guess that this way, right, going towards that direction, that car is going east, right? So we're describing this vehicle going at 20 meters per second towards the east. Make sense? All right. So how far would the car travel then in 10 seconds? How far would the car travel in 10 seconds then? Well, that's pretty simple, right? Because we already had a formula that was v equals d divided by t, right? So now what we need to do is solve for d, the distance, because we got the velocity from the last problem, right? And we have the time coming from this problem. Easy, right? Very easy to solve for d here. All you have to do is multiply both sides by t, right? Multiply both sides by t. That's a t there, not an f. Sorry, right? So these t's cancel out, and then this t multiplied by that t makes it vt. Vt. Oh my God. Vt equals what? D. So all you have to do now to solve for that problem then is what? Multiply 10 seconds here by the velocity there, right? So what was our velocity from the last problem again? Anybody remember? It was 20 meters per second, right? Times 10 seconds times t. I don't know why I put that there. Times 10 seconds, right? The seconds cancel out. All you get left is the 20 miles or meters. 20 meters times 10. So that's 200 meters. Your d equals 200 meters, right? So those are the kind of problems I'll be giving you for this particular unit. It's a good time, I think. Let's try another problem. I know there are a lot, aren't there? There are a lot of problems. You know, they tell you in the course description that this class is supposed to not be math focused, but then they give me these lectures to do, and it's got all these math problems in it. And I'm like, really? I have to relearn my math so to teach these people. Um, just joking, joking. Okay, so how long does it take sunlight to reach the Earth? That's the question here, right? That's the question. How long does it take sunlight to reach the Earth? So this again is another easy problem, right? It's the same kind of problem as the last problem. Pretend that the speed of light is like the car's speed. So the speed of light here is 3 times 10 to the 8th meters per second. Okay, and it's traveling at a distance of either 93 million miles, or we like these metric system here, so we'll go with 1.5 times 10 to the 8th kilometers. Okay, so we're already given d and we're already given v, right? So we'll go back to our original equation, which was v equals d divided by t, right? We'll rearrange it so that we get t by itself. That's quite easy because it's, if you look at this problem like it is a math problem right here, that v is over a 1, and then t, why do I keep on drawing f? That's so weird. T is right there, right? Like that. And quite literally, you can just switch their places, right? You can just switch these two right here. You can put t over there and v down here. So now, t equals d divided by v. It's called cross multiplying, remember? Okay, so that's pretty simple. All we have to do now is put the distance, which is 1.50 times 10 to the 8th kilometers. Man, my pen's so responsive now, not like last time. I was getting pretty upset last time that my pen wasn't working, right? That is divided by the velocity, which is 3.00 times 10 to the 8th meters per second, right? Meters per second. Let's do the calculation real quick. I brought a calculator with me. I thought I did. Where's my calculator at? Oh, there it is. Okay. Clear, 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 clear. So this is actually really easy. Like, if you forget about having the scientific notation there, right? Forget about that part. This is literally 1/2, right? 1.5 and 3 is 1/2, right? So 1/2. Yeah. Oh, I'm so sorry. um. Yeah, I know, right? These metric system people. These metric system people, man. Oh, okay. I got you. I got you. I got a little confused here. My bad. I did it in my head and I forgot to write it down. It's actually supposed to be 10 to the 11th meters per second. Like if you convert this kilometers to meters, it's 10 to the 11th. I forgot to change it. I'm sorry. So it should be 10 to the 1.5. 1.5 times 10 to the 11th meters is what it should be. Sorry about that. Forgot to convert it. Okay. Which it's easy, right, to just convert this to meters. Why? Because you're going from meters to kilometers or kilometers to meters, right? So all you have to do is move the decimal point how many places? 3 places. And if you're doing scientific notation, moving the decimal point 3 places means what? Adding 3 to the exponent, right? It's the same thing. Anyway, so we calculate that out, and we get t to be 0.5, right? Because it's literally half. Oops. T to equal 0.500 times 10 to the third seconds, right? Because just like Gloria there pointed out, we needed to have this the same unit, and the reason why we needed to have it the same unit is so that the m's cancel out. So all you're left with is seconds. And then, just to make this number a little easier to read, you can convert that back to regular numbers, and that's just literally 500 seconds. That's all that is. That's 500 seconds. So that's a good point there. Make sure that when you do these calculations, that you make sure your units are all the same. And if you have to, go through and convert them. For me, I was writing it down and I just totally forgot that I changed that to that I made that 11. So that would be meters instead of kilometers. Everybody okay with that? Literally, it's this, distance divided by that. I guess the hardest part of this was to convert kilometers to meters, but literally it's only 3 spots away. So you just have to add on 3 to the exponent. And so there it is. 500 seconds. Good job. Good job, team. Good job. All right. Next question. Do you guys need me to scan for you again? I feel like a tourist, like going around taking pictures for people. Oh, wow. This one's not working at all. What the heck? The hell with it. We'll just skip that. Well, we're not going to skip it. We're not going to, you don't have to scan that one. I don't know why that doesn't work. Anyway, so which one is the value of the speed of light? Oh, I know why it's not working. It's cut off up here. Somehow this got cut off. Look at that. That's crazy. Crazy, crazy. Which one? Which is the value? Which is the speed of light? Huh? Everybody says B? Everybody says B? Actually, it's all the above. Because if you convert this, which is what I told you in the last slide, to miles per hour, that's how many miles per hour it is. If you convert this to miles per second, that's how many miles per second it is. So be prepared for that type of question, right? And don't be fooled, right? I'll give you some kind of thing, some kind of stop constant at the speed of light, but then I'll have the other answers be converted units. So just, don't fall for that. All right. Let's try another problem, okay? Let's try another problem. This one's going to be a little bit more complicated. What is the average speed in miles per hour? By the way, miles is MI, not M. I keep on saying miles for the other one, but the other one was meters because it's just M. Anyway, what is the average speed in miles per hour of the Earth revolving around the sun? How do we solve for this one? Well, and don't worry, this will all be recorded. The first thing to note, right, is that you have the time, right? You need this right here. You need some kind of time. And your time is 365 days, okay? Because the Earth revolves around the sun in how many days? 1 year, right? And 1 year is 365 days, okay? Next thing to note is that you need the Earth's radius from the sun, like the distance the Earth is from the sun, right? And the reason why you need that is because you can use the formula for circumference of a circle to figure out how far it's traveled, the Earth's traveled, right? So let's do this one step at a time, okay? So you know that this is a circumference problem because it's asking for the Earth's revolving around the sun. So immediately you should know that you're looking for the circumference, and the circumference equals um, 2 pi r, okay? 2 pi r. Just so you knew, if you didn't know this already, if you're looking for the area of a circle, it's pi r squared. If you're looking for the volume of a sphere, it's pi r cubed, right? But right now we're just doing circumference, right? So we know that we need that formula. So let's just take this one step at a time. We have 365 days, and we need to convert that to hours. Well, that's simple, right? 365. Let's hope I don't screw this up and Gloria catches me again. Days. At least it wasn't both Gloria and Hanukkah this time. Okay, days. All right. And then we want to get rid of days, so you put days at the bottom. And then every day has 24 hours, right? And then that should give you what you need. So the days cancel out. And so all you really need to do here is multiply 365 times 24. 365 times 24. That gives you a total of 8,760 hours, right? So we've taken care of that part already. Next thing to do is to do the distance that the Earth is traveling, which is the circumference of the circle here, right? So if this is the sun right here, right? And then the Earth is traveling around the sun like this, right? It takes the Earth 365 days to go around the sun, okay? One circle. And then the distance from the sun to the Earth here is the radius, right? And that's what it's asking for in 2 pi r. So distance equals 2, right? What's pi? 3.14, exactly. We can take it out to a few more digits than that, but that's okay. And then you multiply that, right? By what? By the radius, or the distance that the Earth is from the sun. Okay? So that's 9.30 times 10 to the 7 miles. Right? So that's just the distance right there. We still want the speed. Right? We still want the speed. What's the average speed? What was the formula for that? That was V equals D divided by T, right? For the speed. So quite literally, all you have to do now is put under this number the time it took that you calculated here, that you converted, right? So that's 8,760 hours. So we do order of operations, right? Please excuse my dear Aunt Sally. We'll do the numerator first. So yeah, by the way, this is no longer just distance, right? Now this is actually v, right? For velocity. Please excuse my dear Aunt Sally. We'll do the top first because P stands for the P stands for what? Parentheses. So we'll do 2 times 3.14 times 9.30 times 10 to the 7th. And then we divide all of that. We divide all of that by 870. Okay, we divide all that by 870. I mean, sorry, 8,760. And that gives us okay. I got 6.67 times 10 to the 4th miles per hour, right? And then we can make that number something a little bit more normal looking, right, for miles per hour by moving the decimal point over, right? We have 4 exponents there, right? So we can just move this decimal point right here over 4 times, okay? And when you do that, you get your average velocity to be 66,700 miles per hour. Holy crap, that person's traveling fast. Right? Do we have the right number of significant figures? 365 days, yes. The radius here has 3 significant figures, right? And we have how many significant figures in our answer? 3. Right? Easy as pie. Easy as pie. Everybody get that? All right, let's keep on trucking here. Okay, so what then is the average speed in miles per hour of a person at the Earth's equator as a result of the Earth's rotation? So before we were talking about the Earth traveling around the sun, right? Now we're talking about a person standing on the equator of the Earth, just going around in a circle, right? Because the Earth spins in a circle, right? Okay. So how much is Earth's rotation? Earth's rotation is literally 24 hours. It takes 1 day or 24 hours, right, for the Earth to rotate around once. Okay. Luckily for us, this is the exact same equation as before because the person standing at the equator is traveling a distance of the circle, again, the circumference. So we're going to use 2 pi r again. Oops. 2 pi r should be 2 pi little r. 2 pi r again for the circumference. Okay? So we have the radius here too already. Thank God for that. It's given. So circumference of the Earth equals then 2 times pi, which is what again? 3.14 times the radius of the Earth. I always forget to put in my units. Don't do that. You'll get the answer wrong. You don't put in your units. Right? Miles. So just so you're understanding the question, right? Here's the Earth. Okay? And here's the equator right here. Right? Here's America, and there's Florida. Right? And there's South America. Right? Okay? And there's a person standing right there, maybe near the Panama Canal. That little guy right there. You see that little guy right there? And he's traveling around as the Earth is rotating, right? And we're trying to figure out how fast he's going. Does that make sense? Okay. That's actually a really good picture of the Earth. I've never drawn a picture of the Earth before. So this is so simple now because it's the same equation again. V equals dt, right? So that means it's, oh, I forgot to answer this question. What is this? I was like, what is that? So what's the circumference, the distance we're traveling? Let's do that real quick. 2 times 3.14 times 4,000 miles. Okay? That person traveled a very long distance, 25,000, oops, not 24, 25,120 miles. Man, just standing there for a whole day, that's how much you travel, right? And then all you have to do is divide it by the time. What's the time? The 24 hours, exactly. 24 hours. Good stuff, right? Do that. Divide it by 24. And I get, actually, something very interesting. 1,046.0, 0.6666666667. Is that ever the right answer? No. You've got to use the right significant number of significant figures. We have a distance here that is literally one significant figure, right? It's one significant figure. If it had a decimal there, it would be 4 significant figures, but it only has one. It doesn't have a decimal at all, so it only has one significant figure. So since that is true, your answer will be rounded down to 1,000 miles per hour. What if there was a decimal point there and there was 4 significant figures? What would the answer be? Exactly. Actually, it'd be 1,047, right? Because this 6 here makes us round that up to 7. So it would be 1,047 miles per hour if there was a decimal point right there. Right? That is good stuff. That was good stuff. I think that's actually a good point to stop because we'll talk about acceleration on Monday. Okay?